All right, for number 27, we're given two functions. F of x is equal to the square root of x plus 5, and g of x is equal to x squared plus 4x minus 1. And we're asked to find f of g. So for f of g, we're gonna take g of x and we're gonna plug it in to f of x. We're gonna plug that in for our x value in f of x. So we're just gonna write out f of x, but we're gonna replace that x with g of x. So this is x squared plus 4x minus 1, and then the plus 5. All right, now notice that we've got some like terms that we can combine here. -1 plus 5 is 4. So this is the square root of x squared plus 4x plus 4. Now we may be able to simplify this some, so let's try factoring that trinomial there. If we factored that, to get x squared, we're going to need x and x. And then to get the 4, we're going to need either 4 and 1 or 2 and 2. But we need them to add to 4. So that's going to be 2 and 2. And they're both going to be positive. So that's x squared plus 4x plus 4 factors into x plus 2 times x plus 2. Now, x plus 2 times x plus 2 is just another way of saying x plus 2 squared. And now you can see that this square root and that this squared is they're going to cancel each other out. So this is just x plus 2. Now, the last thing we want to do with this is go back up here to f of x. Notice that f of x can't be negative because of that square root sign there. We can't plug in anything that's going to make this negative. Otherwise, we're not going to get a real solution. So, so f of x has always got to be positive. Now, because we've plugged in this value for g of x that worked out really nicely, and we were able to cancel that square root, we've now got an answer down here that could be negative. And so we want to make sure that whatever answer we get down here, it's got to be positive because f of x can't give us a negative number. So to do that, to make sure that this is always going to be positive, we're just going to put an absolute value symbol on that.